Hey guys, Mr. Milton here. Today we're going to talk about writing exponential functions. At the end of this video, you should be able to write an exponential function from a graph or from 2 points. Okay, what are two things do we need? What two things do we need to write an exponential function? Remember, that is the initial value a and the growth or decay rate b. And from our shortcut, we should be able to find the initial value pretty easily. Remember, the initial value is always going to be the y-intercept. So here our y-intercept happens here at 4. And we can tell what our growth or decay factor is by looking at what it goes to next. So as we go to the right at 1, we see it a point here, 5, 6, 7, 8. So it goes from 4 to 8. And we'll find our growth factor, say how do we multiply or divide to get from 4 to 8? That means we multiply 4 by 2. And so that 2 is our growth factor. So now that we have a and b, we can write our function as y equals 4 times 2 to the x. And that's our function. Okay, try the same thing here for this next problem. You can pause and give it a try if you'd like, or you can follow along with me. Okay, we see that our y-intercept happens at 15. Our next point at 1 is at 5, so we say, okay, what do we do to 15? What do we multiply 15 by to get to 5? Well, we multiply 15 by 1/3. Okay, and that means that's our growth rate. 15 times 1/3 is 5. And so now we have our function. Y equals our initial value, 15, times 1/3 to the x. Okay, so at times we are going to be able to write or asked to write an exponential function based off of a graph, but we'll also be able to be asked to write an exponential function given 2 points. Okay, so here are 2 points, 112 and 236. Which letters do these represent? Remember that these are coordinates, so they represent x and y. They are not a and b. Okay, so plug in those values and we will have a system of equations. Okay, so these represent x and y, and so I'm going to plug these in. I have 12 equals a times b to the x. Okay, in my second equation, I'd have 36, again that's y, equals a times b to the x. Okay, now we'll have a system of equations, but these are not linear, they are exponential, so that means we'll have to solve them a little bit differently. So with linear systems of equations, remember we multiplied and added them together, but because these are exponential, then we won't add and subtract the equations, we'll actually divide. So essentially this is like a fraction. Okay, I'm going to help ourselves out just a little bit. I'll keep it this way, it's fine. Okay, so this is how we're going to solve it. We're going to divide these two equations. Okay, so I have 12 divided by 36. I'm just going to simplify that to give me 1/3. A divided by a gives me 1, so they kind of cancel each other out. B over b to the 1 over b squared, that will give me, let's say, b to the negative 1, right? Okay. Or I could rewrite it as 1 over b. Okay? So notice that the a value cancels out. Because of this, we can find the value of the other needed piece, our growth factor. And now once we have that, we can plug it in and solve for the other one. And so, as you see, we have 1 over 3 equals 1 over b. And so you should be able to see pretty easily, if not you can cross multiply, that b is 3. Now that we know our growth rate, we can plug that back in and we can solve for a. So I'm going to plug this back in. I have 12 equals a times 3 to the 1. And now 3 to the 1 is just 3. I'll divide both sides by 3. And a will equal 4. So our initial value is 4. Our growth rate is 3. And so I can write my equation for the system as y equals 4, 3 to the x. Okay? Alright, let's flip to the back, try it again. Okay, so now given some points, we are going to write the exponential function that goes along with these points. Again, remember that we're given x and y. I'll go through a couple of these with you, and then I'll have you do the other couple on your own. So, I'm going to plug these in. Now, what I usually like to do is keep the bigger number on top. Bigger y on top. Helps me out a little bit in situations because then I can avoid negative exponents. Okay, so I plug 96 in for y, 3 in for x. And then I'll do the same thing. I'll plug 48 in for y and 2 in for x. That's the exponential system of equations. So now I'm going to divide. 96 divided by 48 gives us 2. A divided by a is 1, cancels each other out. And then b cubed divided by b squared, remember that means we're subtracting, and so we'll get b. So b equals 2. Now that I know that b equals 2, I can plug that back in to my system and find out what a is. Now I'm going to plug b into the second one just because the numbers are smaller. But you can plug it into either one. It will work either way. So a times 2 squared. 2 squared is 4. So 48 equals a times 4, 4a. I'll divide both sides by 4. And I'll get a equals 12. And so now that I have a and b, I'm going to write my my equation for my exponential function as y equals 12, 2 to the x. Okay? Alright. And so again, you can see that b is greater than 1, so it's a growth function. Let's see how this works when it is not a growth function. Okay, so let's look at number 2. Number 2, I have 5, that's my y, equals a times b to the x, in this case x is 2. Then I have 20 y, a times b to the x, which is 1. And now again I'm going to go through, I'm going to divide everything. Okay, so 5 divided by 20 simplifies to 1/4. A divided by a, remember, cancels out. Essentially, it's 1. And then b squared divided by b. Okay, leaves us with b. Okay. Okay, and now we see our growth function, or now in this case we can understand that it's a decay function. Our decay rate is 1/4. We can plug that back in to find out what a is. I'm going to plug it into the second one because smaller numbers. So 20 equals a times 1/4 to the first power, so it's just 1/4. Now to get rid of 1/4, remember we have to do the inverse, multiply by 4. And so a will equal 80. And so here's our function. Y equals 80, 1/4 to the x. Okay, so the process is pretty simple. try these next two with it, okay? Make sure you plug in x and y, set it up as a system, divide your equations together. That should cancel out a. Solve for b, plug it back in, and solve for a. Alright, try it out, bring it back to me with 3 and 4 completed. Alright, see ya.